discuss. Speaker, he's a dear friend for many years now, and he's coming back to Lucknow after 7 years. He last joined us in Rosario in 2018. So I'm very happy to introduce Harvey Allen. He's the Deputy Director of Network Startup Resource Center, and he is once again joining us here in Lucknow. We have a long-standing friendship. We had some distance because of some work stuff, but we are great friends. And he's here with us once again. A big round of applause for Harvey Allen. And he will speak about opportunities for cooperation in Latin America, a workshop for hybrid strategies, and so on. So without further ado, I give you Harvey Allen. Good afternoon, everyone. It is my pleasure to be here in El Salvador. It is my first time here. I have traveled around. I lived in Chile for 10 years, but I am finally here in El Salvador to see this beautiful city and beautiful country. Thank you so much for inviting me here today. And my organization works in agreement with LACNEC, and I'm happy to be here to discuss what we do. This is a very long title for my presentation, but the idea is to show who we are, what we do, how we can work together, or maybe some of you who are joining us remotely. And I will give some semi-technical examples on how we carry out our activities, how we train, and so on. So this is an outline of my presentation. And I usually walk across the stage, but I will try to stand still. I will speak about us and some of the activities we've done over the course of the years and the technical type of workshop that we have for people. We many times visit universities, but we work with registries and groups that are running DNS, and we organize workshops and work in person. Oh, great. Thank you for this. Okay, I feel better that I can walk freely across the stage. So I'll speak about how we work and what we need to work on site on our virtual training platform that we've created. Many people have done the same around the world. How we do it physically on rack servers and on the cloud, why we've chosen the cloud we've chosen, and I will also describe a new course that we have on virtualization. We've called it hybrid virtualization. The idea is that when we visit some place, we teach how to use the cloud or how to run your own virtualization servers. Our mission, I usually don't like to have such that much content in my slides, but our objective is to help people connect effectively to the internet in a format that promotes research and education. Our funds, since the beginning, have come from the US government, but nowadays from other organizations like ISOC, ICANN, Google, several providers, and so on. And the idea is to improve the possibility for scientific research and also help the economy and the internet in developing countries, the development of the internet in different countries. We are not a for profit or commercial group, and we are not trying to sell anything or earn anything. It's just our life mission, actually. We are lucky enough to be able to do it. So, what's my group? It's NSRC Network Startup Resource Center. We've translated it into different languages, but basically it is a group to help developing networks. Randy Bush is our founder. Some of you might know him. This was back in 1990. And Randy have a friend, John, who worked at the University of Boston, MIT. And in 92, the US NSF gave us a scholarship or a grant to take these lessons worldwide. Randy visited different countries and he helped connections in our first countries. So that's for people doing research, professors, and scientists to communicate and finally transfer data among them. In 1996, we switched to the University of Oregon, where we've been since then. It's a different coast from the east to west. Oregon is in the northeast of the US. So it's a university of around 25,000 people. I would say a mid-sized university. It's not as technical as the MIT, right? But it is a great place. Randy used to live there, so that's where we've been since then. Here is we have different contractors and people working with us full time. We have a group of technical experts in the different fields. We work vastly, for example, with BGP, routing, space. We work with DNSSEC, RPKI, and managing and monitoring networks, monitoring systems. People nowadays are more advanced compared to what we were 25 years ago. So there are very few people that help us, that ask for help running an operating system nowadays. Rather, they come with more technical requests. So we reach out to people in different regions. It is always better to have someone locally to teach locals. In Africa, for example, we have several. We have had 10 to 15 workshops and events in Africa this year. We usually have locals and someone visiting from Europe and the US, and we always have sort of a mixed events. In Asia, we also have a group of people, Australia, New Zealand, Guam, right here, and Hong Kong. I've just came back from Mongolia, which is close to China. We had a big event here, and I visited, and I traveled to Mongolia, and then I came here. A big trip I don't normally do. So right here is our city, the University of Oregon. There's snow. We're big fans of football, and Donald Duck is our mascot. We love it. We love charge of the help desk at the university for the university. I went to Pomona College. I worked here for many years and other non-profits like Net Corps, and lived in Santiago, Chile for 10 to 15 years, where there are high buildings and even higher mountains. So when we started, as I said before, Randy Bush and a smaller group started helping different countries connect to the internet: Egypt, Indonesia, Kenya, Saudi Arabia, Tanzania, among others. So this was through satellite and the UCP protocol back in the 1990s. For example, how we sent an email from a country like South Africa to the US in 1990. This was a bit more complex, and that's how we started. Then we started with the exchange points in different countries and in Latin America and Panama and in Peru. And then we helped Peru make their first connection. We've worked in different countries in Latin America and the Caribbean. And here we have a group of IT experts working on an exchange point that was quite high in Haiti. And this is when we started interconnecting the ISPs on the island. So that's what we've done over the course of the years.
And we have here about 1,200, and this is, conferences in front of a big group or a workshop, or even what we call direct assistance on engineering. Direct engineering assistance. So I will explain this a bit more. So we have been to all these countries. This is a case of Latin America. This is our history, and you can see Central America and the Caribbean most of all, as well as the northern part of South America. This is since 1990. And then over the past 15 years, we have worked in about 60 different places. Some of the good memories of working in the region. I always like to show these pictures. I have lots of pictures. There's some people here who were also involved in this. This is just an overview of some of the workshops we organized. We always have a lot of technical books. We worked with groups to build things. This was, for example, helping the registry in Costa Rica. We did also walk in Merida, and walk was quite big for some years. Here we are in the Galapagos Islands, where we connected the station in Darwin to help them get connected to the network for research purposes. And as you can see, in 2020, we went virtual. And this over here and this other event is because we had to invent how can we do what we do virtually in something that we can take through a server, a rack, or through the cloud. And COVID was a reason why we considered this and built something in this direction. Then LAC TLD in 2020. This was typically with Zoom. We interconnected all the people. This is helping with an IXP in St. Kitts and Nevis in the Caribbean. This other one is in Panama, and finally in El Salvador now. And also Cuba. We were twice in Cuba in the last walk, and this year we'll have one in person and virtually. So what are the types of workshops that we have available for those who might be interested in working with us? Here we have the long list. You can barely read it. You can enlarge it if you wish. So we have several types of workshops: DNS and registry operations, network engineering and operations. This is what our focus is on, as you can see here in the middle. Then system administration, and we also have workshops on training the trainer. So we provide training to the trainers who will be giving these workshops. So we organized a large number of these, which was very helpful. So simplified, these are the different topics. What you have on white are the most popular activities, what people ask for more. What you see in yellow are things that are possible. If you're interested in this, we can organize workshops like those, but these are less popular. And the ones that are most popular of all is what we have: design and operations of campus networks. This is how you can design a network at a university, starting from stage 1 through to stage 7. Wiring, fiber optics, how you place the fiber optics, all the different methods, then how we'll do the switching, the routing. Then if this is a university that has more than one connection, how this is done, or if they will have to use BGP. So they have to understand this as well, how they prepared the entire setting. Then NMM is network monitoring and management, and then workshop on BGP, how to prepare a traffic exchange point. Then cybersecurity for internet operators. Many people ask us for a course on cybersecurity, and we also always say, well, what does this mean? Because everything is security. Whenever you start to set up an operating system until you build the network. So we teach cybersecurity in everything we do. So network management has an enormous section on cybersecurity. And finally, we organized a 1-week course on cybersecurity with a focus on the physical side of routing and switching. And one new thing is virtualization and cloud computing. And then a workshop on the NRENs, that is to say, the National Research and Educational Networks. We do a lot of work with them. So how do we work? If you ask for a course, what are the steps that we follow? Above all, my group is focused on the applications. We never go to a place to say, you need this or whatever. This doesn't work at all. If you go somewhere and say, well, I think I went to university and it seems as if you have problems with your routing system or with security, you need this. And this does not work. Very often people say, well, thank you, yes, do come. But that does not work like that, because they don't have a group that really wants us to come, the group that has a plan and what they're going to do if we go. Or they have to speak with a supervisor or with their boss, say, well, we need assistance with this. And then you have engineers who might be interested in this. So always we respond to the applications. We also involve the local engineers, and this is of critical importance, because if your boss or an administration tells us, do come and prepare our network, but we don't have the support of the local engineers, well, this doesn't work. They say, well, what are you here for? And we say, well, we do the things and you know how. So we always have to have something that is bottom up, of course. The engineers who tell the administration, we need this. And then the managers, which is top down. So both have to agree on that thing, the point that they need something from us. We never assume things. So very often we start saying, well, they won't understand this or that. Why did you purchase it? So you get there. No, it's totally different from what I had thought. So we always have to learn what is happening when we go to a place. So you have to listen and understand the request or application, and then depending on the type of request, we proceed to planning. We ask for information on the organization where we're going to go, what they need, and to select something that can be solved. There are things that it's impossible to solve, at least at this moment. Maybe we can prepare something for the future, but you cannot prepare something for something that it cannot be solved. And then to involve the local engineers and managers. We never try to dictate something, we just recommend things. We teach and let the local team do the work. Let me give you an example. We go, we teach something. Maybe this is helping a university, and we need to prepare the switching teams and all the fiber optics. So the first time we take a step and they look at what we do. The second time we don't do anything at all, but we look at the people doing that work. And then we try to repeat this as much as we can. And although this is a slow process, if we do it in that way, it is necessary, because if you leave and people locally don't know how to do this, this won't work. Therefore, we work together side by side, and then in the end, we deliver a plan, a report on what we did regarding the way forward. An example that we have seen in many universities, you have a connection to the network, for example, a 10 mega connection. And there's something I need to switch off here. Yes, it's a bit better. Okay, now. So we get there, and they've had a connection at a given speed at the university. They've had that speed for many years. The network works in a given format. Okay. You just received a 10 or 100 times faster than that. They're most enthusiastic about this. Finally, we have fiber optic at the university. Everything will work fine, and we don't note any changes. That's typical. Now, in general, this is because the network was set up with a very slow connection. So to rebuild a network so that they can use a faster network, there are many steps that have to be followed to do things properly. One of the steps that we often have to take is that very often you have a router, a border router, then you have a big switch, and then you have a second switch, and then you have a third switch, a fourth switch, a fifth switch, and there's no end router. And everything is interconnecting the entire organization without using routing. This works more or less and to a certain extent, but obviously this won't work for an entire big organization. So we have to reconstruct things. We have to reconstruct the way the network has been set up. Very often we go to a large institution and you can't do everything at the same time. You just focus on one building or two buildings, and then when we live and have time, they now know how to do this, and little by little they can build the network. So at the end, we have a plan, we have a document, and we have diagrams and everything that they will need. And if possible, we can also take devices. In the past, we used to send devices everywhere: routers, switches, optic fiber optic, and Wi-Fi, all those things. Today, it's very difficult to do so. And I guess you know why. This is because of the licenses of the operating systems of the routers today. If you leave a Juniper router, a Cisco router to a group, then you will have a certain amount of software running there, but without licenses. So there will come a moment where this is no longer working. You have to pay for this. So paying the software license very often is much more expensive than the device itself. So sending devices that are older with software that barely runs, well, this won't work well in the long run. So whenever we can, we do something more serious with licenses, but it's very difficult to achieve this. We're not just going to purchase things and send them. So we work with a group to understand how they can obtain devices such as these. So this is a fundamental change that has taken place, but this is due to the licenses of the devices that there are available. When we go, if we're going to give a course, we always try to make the people invite their close friends. So if it's a university, it's not just one university to teach just one course. Maybe the course has a couple of engineers and someone in charge of the network. So it's not worth if it's such a limited number of people. It's just one institution and few people. I say, well, we have a software and we want you to also teach all these things to the students. And we say, no, it's great to have some students who study software engineering, but if not in the campus and setting up the network they're trying to help them with, this won't be very effective. So a good effect when teaching students on how things work in the real world, but they don't really have the opportunity of doing this for a couple of years more. So we always say, why don't you invite the engineers from the region? So we try to organize with a group, 20 to 30 people. And normally this works well and better because the university now will have people they know who are at another university, or they will have someone from the research and education network. So when we do this, we ask the locals if they can
allow him
for accommodation, transport locally, food, and provide the space we'll be teaching and the coffee breaks.
And in general, this works well. At the university, there are always places where we can stay. Food is not expensive, it's not complicated. We pay for airfare and our salaries. So this is something that they will do locally, and then we pay for the rest. In some cases, we also provide scholarships. Many times we have granted scholarships for women to attend, and we pay for their accommodation or airfare. So, what do we need once we get on site to be able to have an efficient workshop? Five things. And the last one is, in general, the most important. One, connection to the internet. Nothing fancy, just a single connection to the internet. There shouldn't be any firewalls. It should be 100% open. I know that in many cases that will not be possible. It will not be allowed. It's okay. We understand how they work, but we always request it because it's easier. A public IP address, if it's public, is better, but it's just a way to get out of the local network, and then we interconnect the private network when we are teaching and working. We like having UPS. It's not always possible, but we like to have it for the equipment that we work with and the projector, and so we are able to continue working if there is a power outage. Tables, we usually don't think about it, but we try to work with our students in groups. For example, a group of 6 people, as 6 people represent the university working together. So having a table where we can fit 6, and then, well, more tables for the rest of the facilitators, and so on. A whiteboard or a screen where we can write, either one. And what is even more important, and usually we don't think that is very important, but it's actually the most important. So we can plug in our devices. It's incredible how many times we have 6 people, 6 laptops around the table, and we only have 3 outlets. So an extension cord with many outlets, it's, well, sounds silly, but we usually end up having to buy locally, having to find somewhere to buy it. And that just happened in Mongolia. We were at a great hotel, everything was great, and they had 5 outlets, but we had 6 tables, 36 people, 8 teams, 2 screens, 8 devices, well, whatever. We needed more outlets. I said, I need 7. I said, 7? Well, that's too much. Well, yeah, we needed 7. So finally we got those 7. So connectivity, electricity, extension cords. I'm not sure if that is the word in Spanish or the word in Salvador, regletas. Alargador is the word in Chile, which doesn't make much sense to me. And these are other Spanish words across Latin America for an extension cord. So this is all we need. After we have all of that, we are good to go. But we in advance have had to bring all the switches and a full whole lot of equipment in a box. We need a PC per person in the past. Now we have portable computers, which is easier. And now we need to have the VTP platform, the virtual training platform. And probably you've seen this before. We created our own platform that we call VTP. And there are many ways of doing it. And this is something very important in what we do, particularly for groups. And we make it available to all. We have several friends, for example, in Uganda, Kenya, Bhutan, several places that already have their own VTP and teach courses after we leave. So if you're interested in this, in adopting it, we have documentation, we show how we do it, etc. So that's the device that we take, the hardware, the physical hardware. This tiny one right here is an Asus NUC. It's very small. It got 128 gigabytes for RAM, 2 TB hard drive, and we have a workshop for 40 people using 6 virtual machines. 5 years ago, we would need like 2 or 3 of these. Nowadays, it's much better. So what is important about these small devices is the color, right? That is the biggest problem usually. The memory, hard drive, the DNA that we use, and of course, well, the heat, I'm sorry, that it causes to the device. A switch, small switch from Unify. There are several small ones similar to that, but we want it simple. That's the main idea, to have us to make it easy, to make it simple, because the more complex it is, the more likely it is to cause trouble, or we would need to work on the settings, and that wouldn't make sense. Unify has this unified device has 4 PoE ports, one single plug, and you can connect and have VLANs and so on for it to run effectively. It is super light. That's why I like it. It's really very light, and I can carry it in my backpack. And we usually use Unify just because it's the smallest and they work very well. But you can use any brand or your own system. So here are more examples of things that we use. Netgear, GS110TP. It's been very popular for many years among the small switches that run effectively. So that's just an example of what is out there. With this, we can build something similar to that diagram. We have network monitoring. It's a virtual environment with 2 transit routers, one border router in each campus. This is a campus, and campus. We have a main router, and different switches. And within we have a server that is running, and below that several hosts running containers. And I will show this in more detail. So we will have a very small box using Wi-Fi, connecting the entire group, and it works well. Here we have another campus in more detail as to what they have. We have a server, and this server is running the 6 hosts in different containers, the virtual servers running within the NUC. And this is all that we have in the network per campus and how it works. When we run a management course, we're going to monitor all of this. We use all the tools, graphs, we show everything. And this is how students or participants can deliver. And this changed since the beginning. This was LAC KLD in 2020. We taught a course with all of that. So to do something remote when you are not there in person, and when you want to connect, it would take half a day to connect SSH, to teach people how to connect, particularly Windows, version 10, 11, 11. Well, so I have the type of SSH that I like. Well, I have PT. Well, with 30 people, it's just with Mac or Linux, it's instant because they all run SSH and there's a single space. So we decided, right, this is not going to work. We have a console, and we invented a web interface, and the person just accesses one page with their user, and they'll have access if they're working on campus number 1. There's one option for every type of workshop, so they'll have access to the console, routers, and switches. We use a different software, the SSH, to everything. You can choose and pick. You'll select a tab into Chrome or Safari or whichever you are using. You open it and then you are connected. You don't even need to use a username. That is not important. What is important is to convey the ideas. And then you have a web per each machine. We're running a web server with different things. We also have a network operating center that is running more quickly with all of these software. Nagios, Smokebang, Netbox, and so on. It's already set up and it is accessing all campuses. It has access to see everything since the beginning. And we teach all of this during 2 weeks, how to do it yourself. So we have Nagios running. You already have a graph to all servers that are running. And in red, you can see, for example, when you are running 8 workshops on network design and you have more things. When it's management, you have fewer things. And the same with Nagios, that, well, looks similar and we to what we saw before in the campuses. So how do we build this environment? Well, several things. I just left a comment here by mistake, but we've documented all the steps. It's like a book, it's quite thick. We have all kinds of workshop, all of the scripts that we do, how to install it, the different versions, and we maintain this running all the time, up and running all the time. So this book is available to anyone that would like to do this on a website. We use bash scripts. In the past, we used to use Ansible. Ansible is not truly conceived for this. Everything needs such differences for users, passwords, and particularly all of these management products constantly change. So you need to change Ansible scripts and so on. So it was easier to just have everything on Bash. We use the scripts and you set everything up. We have instructions on how to install everything manually. So you run the Bash script and we show it step by step. If you want to form all the bridges and interfaces for the network, we show you how to do it and how to set it up. The environment nowadays, we are running it with GNS3. I imagine that many of you are familiar with it. Ubuntu version 22.04, because in order to use this, we need to make some changes. And GSN3 runs well. 92 virtual machines. We use KVM like Kumu with Libert. It is a combination of having a virtual machine running in Linux and the Linux version, and the virtual machines run Incas containers. Incas is the new version for LXCs. How do you call it? This project was forked. There are two ways. LXS Day is one option for the project, and the other one is Incas. So we use Incas that allows us to run containers in each virtual machine. And
And then web interface to access all this. If we wish to see how VM is running, we have, for example, this hardware over here, which is Asus, with this version of Ubuntu with KVM, and within KVM we're running the hosts. But we want the network. This is another part. GNS3 is also running, and this creates a network like we want to have it. And I'm sure that most of you have used this already and are familiar with this. So we prepare different types of networks running the environments that we need. You have a customer that can run wherever, in a laptop, for example, and we use a firewall like UFW to provide access to the network. This is an example of how an IP is allowed to connect to GNS3 running on the server. When it is running, it looks like this, for example. It's the same diagram that we saw. This is GNS3, which is running with all the switches and the end routers that we have. In GNS3, you can interconnect the virtual machines directly to the router or to the switch. So that is done by the software. Over here, I can stop and start and view all the virtual machines running. As an example, here I put at the top, I think it's, well, yep, and the campus one, the border, this is the description. I place the mouse over there, and you can see here the console that is running. We are running with Cisco. We don't use the one in Gen S3. We only use images of iOS of Cisco. You can select others if you wish, but this is the easiest one. I don't know whether you use it, but Cisco has the CMLs, the Cisco modeling lamps, the private versions, which cost $200 a year, and read the license, and this is allowed. As long as you're not selling anything, this is allowed. You can run these instances, but we always pay for each instructor a license. And we have spoken a lot with Cisco about this, and I think that we are the reason why they changed their license. We explained that we are doing this and that this laboratory that they have is not worth for what we're doing. So it doesn't have all the things that we need to teach what we're teaching. So with this combination, it does work well. The price of setting up a virtual machine for all the people with all the things you need, it's the hardware you need, and a license, a Cisco license, so altogether is what is included in that payment. In the Genesis 3 environment, everything is interconnected. I showed this several times, and this shows that server number 1 is running containers. This list is of all the containers that are running in the virtual server. Over here you have the hosts. The participants generally don't know this. This looks as if these were 7 machines, and many ask us, how are you doing this? I don't understand this, and we have to show all this to explain it. During COVID, we said, well, we need to have this virtually, but close to where we'll be teaching, or in the continent or in the region. That is why we went to the cloud. We have servers on racks, and we have individual servers. We have servers mounted in several places globally, and this is very helpful. And we also have portable hardware, but all of a sudden we might be in a region where we need no delay in the communication to the network to the students. So that is where we decided to see whether we could do all this in the cloud. We started to look for a solution, and well, what company? So it was difficult at the beginning to decide whether to use Google, Azure, or Microsoft, AWS. What were we going to use? Now, the most important thing was direct access to the physical servers, so bare metal. And guess who allows us to do this? AWS, nobody else. So Google did have for 1 year as experiment, but no longer exists. They have Ubuntu 18 or something. So it's not useful. Azure is not interested in Linux, but they don't have access to metal. AWS did have. We therefore decided, okay, how much this will cost, because obviously this is cloud-based and it will have a cost. So we started to look for the smallest thing that you can use. This is a version of what we call C5 metal, and this is big. It has a lot of RAM, giga RAMs, and 5 years ago it was about $1,000 a week, or a bit more, because you're going to need many other things. But $1,000 is less than $1 ticket for a trainer to travel to a country. So that's fine with us. For others, it might not be that much. It might be much more. It might be expensive. That is why people use something locally on a rack. This is the cost, for example, of organizing the first cloud-based workshop for LAC TLD for days and a half, including the construction. We left it running so that people could finish the lab. And I put here how much did it cost in the end. It cost $1,050 for 4.5 days. Of course, we had 38 participants from 20 different countries and 4 facilitators. So it's fine with that. Yes, it was worthwhile. With COVID, we didn't have any other options. We have had 7-day workshops with 5 additional days, 12 days overall, and this cost $2,000 to $2,500. It's still worthwhile. We're going to do this again with AFNOG, and we'll walk. We need to have a server that is closer to Africa for all the people who will be using it. And the price has dropped. It has dropped 33%. So now instead of $6.80 the hour, it costs $4.24 per hour. So the price has dropped. So instead of $1,050 in 1 week, it would be about $650 for 1 week. So a bit cheaper. So what is this workshop called Hybrid Virtualization Workshop? This workshop, because we have organized quite a few already, what type of cloud are we going to use for running this? So we decided to teach Proxmox with AWS in one single workshop. Why these two? Well, because we have a lot of experience with Amazon. We also have with Google, with Oracle, with IBM, and with all. I use Linode or DigitalOcean. There are many options, but AWS is enormous. It has everything. People understand it. It contains data centers all over the world. Why do we use Proxmox? Because looking at Proxmox for many years, it was never ready, in fact. And it's now ready. Proxmox has support. It has an interface that works very well. There are several systems that you can use in order to have virtualization, in order to provide services to the people. So Proxmox is easy to teach and supports many types of files. So first of all, we looked at the cloud market. AWS is the leader, followed by Azure of Microsoft. This was 6 months ago. This is the global percentage. AWS has centers in various locations. This is brand new. The one in Chile is brand new. It was just opened. That was one that was missing in Latin America. This is Microsoft Azure. They have got a lot of data centers. This is with all the extras. And this is where Google is located. As you can see, they are quite similar. They have global access. Google has more optic fibers than all. By far, they are well interconnected, but AWS also has a lot of fiber optic between the data centers. Afterwards, we had to decide on the local servers. Previously, we taught something which is called Ganeti. Ganeti was done by Google for all its offices. This was a project, but they don't use it anymore. So this had been developed, but it has made no progress. So we had to look for another type of solution, which was Proxmox. Here I have a lot of things that you have to take into account regarding the goals of this practical workshop. on virtualization of hybrid strategies. And the idea of this workshop is that we get to teach a group, wherever they may be. It was in Bhutan just now, and we can say, well, would you like to use a cloud for your solution, for your systems, for your infrastructure, or do you prefer to build your own solution? It could be Proxmox. You can choose a different one. Many people come because they use VMware, and VMware is more expensive now, so they're looking for a solution. And we always teach that there is no one simple and obvious solution. This depends on your situation, depends on what you want to use, and a large amount depends on whether you wish to have access to your data centers on your cloud. But in Bhutan, they don't have this. If you go, it goes through India and goes somewhere else, like Singapore. And during the week, there were problems with routing in India. So we lost the connection to AWS several times. This was an excellent lesson. I wish you have a business running on the cloud, but in a country where they don't have direct connection to the cloud, think about it, because the network is what is important. So we think that people have understood quite well how much this will cost, how difficult it is, and an important thing is security. AWS is not at all secure if you don't do things properly. So if you have a lot of instances that are connected and are available through the web, it's the same as if you had a server. So you have to include security in everything. And we teach this. We teach how this is done. We also teach how much it will cost, how much it costs. We teach all those things. We teach the concept that a group of servers might have at a data center and one in another center. Or Amazon very often has several groups of servers in one single region.
So these are the labs, and you can see that we teach about different types of containers, data blocks, public cloud solutions, applications, AWS, and so on. So in 1 week, you have all the labs, presentations in Bhutan. This is a mock sample. It's very nice to do. This is an example of what it looks like, how much it costs. We installed an API with Amazon, and we can ask how much every day costs or every week. This DOS instance in Amazon, this is the code that we used, and that is how much a student costs per day: 12, 15, 8, 14, $16. So we can see how much it costs to have this on the cloud, and at the end of the day it costs about $600, and we had 36 people for many days. So to sum up about my organization, it is a nonprofit organization. We work with a request model and listening to people. We have a wide range of technical workshops that we can deliver. We are available to help in different organizations. We have a virtual training platform that works on the cloud with the devices that we bring. We've spoken about our new workshop on the cloud and even local virtualization. We've explained the different ideas, how we teach, our platform, and what we teach. And if you have further questions, if you want to inquiry about working together someday, if well, maybe you are just discovering that we exist, we are available. The groups that funds us, strangely, like my country right now, they want us to work outside the US to help interconnectivity globally. So you can reach out to me, you can send me an email. Our director is Steve Huter. Here you see his email. He's the one who says yes or no. I can say I believe so, but I have to ask my boss, right? Every time. So send us an email if you are interested. If you have any questions or requests, we are available and I hope we can help you in any way. Thank you.
Un aplauso grande para Harvey Allen.
A big round of applause for Harvey Allen. And I think we do not have any questions online. I don't know if we have any questions in the room. Harvey will be here all week, so you can catch him during the break and ask him questions, maybe arrange some tests or meetings or how to get involved. Thank you, Harvey, and I will introduce